First of all, thank you very much for inviting me to this meeting. I'm replacing somebody else, but it has really been fascinating to listen to the various presentations. So I'll be talking about Ssri, and that is the system of Reis-Intensification, but I am approaching it from a wider angle. So don't pin me down on any precise definitions. The system of Reis-Intensification, I must admit, has greatly, profoundly affected the way I look at agriculture and agricultural research. Yeah, okay. Huh? Oh, this spike. How was that? Eavesdropping was that, yeah? But there's a short story to this. Because you have to know that I started my career, okay, among other things, but I started as a postdoc at CIMMYT. This is the Wheat and Maize Improvement Center in Mexico, the Green Revolution Center. Norman Borlaug was director of the wheat program. I was doing in the maize program, but we all were getting this blanket over us about how modern agriculture was going to look like. Yeah? And after that, I moved to another of the international centers, and that was ICRISAT, and they posted this as its headquarters in India, but they posted me in Burkina Faso in West Africa. And there was to look at cereal crops, local cereal crops, so sorghum, millet, maize, and the cropping systems associated with it, so mixed with cowpeas and what did we have more? Groundnuts. And after running that thing 5 years, I said, gee, it's a pity, but we were so thoroughly indoctrinated how to run certain things that you are not even aware that at some stages you make kind of fundamental errors. Not everywhere, fortunately. I had good success, but in some cases I said, oh, I've always been planting too many plants, and I've always been using just too much, even though it was little, too much nitrogen. But you don't see alternatives. You're being so indoctrinated you don't see alternatives. How could you approach it differently? Then, 20 years later, I'm at Africa Rice as an interim director of research. And here comes this package of information about the system of Reis-Intensification, this French priest in Madagascar that empirically develops a new system, basically. And it appealed right away to me. I said, gee, this I should have known 20 years earlier, then I would have had a whole different experience. So that is the background. Yeah? Now, I'm also a very keen gardener, and so that is why I put a number of the color of plants was inspired by your color of science, I must admit. And my home garden, I'm in charge of the flowers, has in the spring, or late spring, has a beautiful combination of colors of this poppy plant. And it makes such beautiful combinations of flowers. The red with the blue and the red with the yellow. And then you should realize that my garden is a very, very poor sandy soil. And it gets very diverse. And to my great surprise, a number of years ago, I realized that some of these poppy plants were growing into enormous plants. And I said, gee, here I have an Ssri poppy plant. It has 200, must have had more than 200 flowers on it over the cycles. That makes my garden so colorful. And so this is the lesson, yeah? That any plant, any crop, develops different, morphology, different phenotypes, depending on the way where you grow it, how you care for it, what kind of management practices you use. Yeah? And so this brings me to the phenotypes and the question, because this is what Ssri is basically about. So here we have on the the right-hand side was the first time I saw Ssri in the field, and I said, this is it. So it is possible, because I never knew for sure whether it would work. A small farmer in Madagascar, the interesting thing is that you see these panicles bending over. It was just a few days before harvest. Yeah? Heavy grains. The interesting thing is that on the left-hand side is the same variety grown by another farmer using conventional methods. The other picture on the right is an Indian farmer, and there you should realize that these bundles of stems that you see have all originated from one little plant that was transplanted early and at the right spacing. Guess my excitement. Oh, no. The contrast here. The contrast here is a conventional rice field planted at high density, and you see many panicles, small little grains. Guess my excitement when the people in India told me, yeah, but the practices that they follow for rice, there are some farmers in the, the winter season, when they grow rice, they start to apply very similar principles. And here you see again this wheat farmer with in his left hand the plant grown under wide spacing, and in the other hand you hardly see it, but that's the conventional plant. Yeah. So on the other side is the proud lady who has her your system of wheat intensification. Guess my next excitement. Oh no, I'm making the same error. Here is the conventional wheat field, planted high density, and you see plants toppling over. That was in the same village. Now comes my next excitement, when last year I find a farmer in Holland who had a record yield of 9.5 tons of wheat, practicing a system that was very similar and used the same principles as you see, as I had earlier encountered in the rice and in the wheat. This guy is the principles that is interesting. The principles are relatively the same, but his implementation is high-tech, mechanized, precision agriculture. Yeah, and you see him here proudly with one of his plants showing the same feature of tillering and producing massively. He won a prize for it. So now we come to the point of what is really Ssri, and I've tried to contrast it in a little table. And on the left-hand side, you have the various practices that make up the Ssri. And on the right-hand side, you have what we call modern conventional type of agriculture. And you see enormous differences. I mean, Ssri doesn't want to say, oh, this is common sense agronomy, this is no... and they don't want to face that the differences are indeed so large. So you work with very low seed rates, very low. Then I say, where we come out is that you can do with 1/5 to 1/10, not half of the rate of seed, no, even 1/10 of the amount of seed. Yeah? And that leads to totally different types of phenotypes of plants. When you transplant these plants young, they have a lot of time to develop. When you plant them single and widely apart, then the competition between individual plants is reduced. Yeah. The fourth factor is that you avoid anaerobic soil conditions. So this goes counter to the Ssri principle that you need flooded rice, you know. No, the plant likes it much, much better if the soil is aerobic, so not permanently flooded. And then the fifth one is that you use organic manure, you use compost. And these were all kinds of elements that were kind of forced on the French priest because he was operating under a situation where there was hunger, so there was a limited supply of seeds. He wanted to make the most of his seeds. There was a drought, so he had very limited water, and the government had stopped subsidizing the fertilizers. So, you know, and then to his great surprise, here were these fantastic plants coming up and yielding record yields. Now we're going to look again, because I'm a field agronomist, so I like to be out in the field. Terrible the whole day in this building, but you have to watch things. So what do we see? Here's an example of, on the right, a plant. Let me say firstly, both plants were seeded at the same date in a nursery. Yeah. The right-hand plant was transplanted 10 days after seeding at a wide spacing, so as a young seedling. The plant on the left was, I think we say 52 days, but anyhow, it stayed weeks longer in the nursery. And you realize that that plant on the left is never going to catch up with the one on the right. And what has the one on the right been doing? It has had the space and the time to develop a profuse root system. Yeah? And that makes the link to some of the other contributions this morning. How important these roots are. Yeah? And the other thing is that it tillers. And the tillering, it makes all these extra shoots, and at the bottom of each shoot, every shoot develops its own advantageous root system. Yeah? Now here's another example. This is a wheat plant in Uttarakhand in India, and I saw it and I said, this is a fascinating plant because you look at it. It has many stems, many panicles. It has broad, tough, dark green leaves. Yeah? In Uttarakhand, this is the outskirt. What do you say? It's the foot slope of the Himalayas. Yeah? So it's steep. It's terraces. As a result, they practice traditional agriculture. No fertilizers. Everything goes with organic manure. So, but this is the type of plant that you get. And my student there, he pointed at this location. He said, you should be able to spot in this picture, among all these terraces, which one is the wheat intensification plot. And it is somewhere, let's see, where was this thing, I think? Yeah. Okay, it is somewhere up here. There's a narrow strip, and the narrow strip is dark green. Here you see it from closer by. This is a student in one of the fields that he runs with farmers. On the left hand is the conventional way of seeding wheat. It's broadcast. It uses high rates of seeds. On the other side, on the right-hand side, is a kind of line planting. They did it mechanically, they tried it, and the machine didn't work very well, and all these problems. But the striking effect is that you have fewer plants, and they are dark green again. So this leads me to some conclusions, or And these are not, I mean, I cannot go into all the details, but we have a number of scientists in India who have really collected the fundamental data. But the conclusion is that in this intensification system, you get higher yields at lower cost. And this makes it a very interesting dilemma now, the controversy. Because the modern science says, this is not possible. This cannot be true. And I had the same feeling for a long time, actually. Can this be true? And it is true, I think. Yeah, because you, let's see, you must link field observations with science. Yeah? So what you see here is plants that have developed totally differently. So they have developed these roots. Yeah? And as a result, they access everything that is in the soil far better. Yeah? So one of the things we are finding, the Indian scientist has shown, that the plant, this modified phenotype, of this phenotype, makes much more efficient use of the resources of water and nutrients because of this system. Yeah? And subsequently, it functions, the photosynthetic processes become much more efficient as well, and they are prolonged. And so the whole process of grain filling is prolonged over the conventional one. And here this Dutch farmer, who is a unique chap, he developed a whole diagram comparing the two systems. He says, you know, when we say the wheat crop is ripening off nicely, it means basically it is premature dying of lack of moisture and lack of nutrient, because there are so many plants and every plant has a stunted root system because of the competition. Yeah? The other thing is, and here we come, he contrasts it with his intensification system. He says, my plants stay green till the moment that I harvest. And he drew the comparison with when you harvest, for instance, berries, raspberries, or apples. These trees are still green when your apples are ripe. He said the same thing applies to the wheat. Yeah? Then finally, there's another aspect of the intensification. By the intensification paradigm of modern agriculture, basically turns around introducing an improved variety, because the local is apparently not good. You plant it at high density, because only with high density can you capitalize on the investment in fertilizers, and can you get the maximum yield. In the process, you create very stunted and weak plants that then you have to protect with all kinds of pesticides and plant protection chemicals. So my initial thought, this intensification system helps you to raise yields and reduce inputs, is totally sound. But, of course, the opposition that we now get from international research and also from the agro-industries, we are set with a modern system that is totally inefficient. And that is the conclusion that at old age I'm arriving at, and which is kind of confrontational, which is not, which doesn't endear me to my former colleagues. So we have been talking a lot about diversity, yeah, so you can question in very diverse systems like rice. You have numerous types of rice. You know, you have rain-fed rice, you have irrigated rice, you have lowland rice, upland rice, mangrove rice, you know, and you name it. There is no single reply. And the single reply has been chemical fertilizer. And there are many, many, I think, alternatives to it. But the final thing, closing, I must say that we tend to make, that's why I got interested in it, say, how do you compare an Ssri system with a conventional system? And that is extremely tricky, because there are all these components in it. So very readily you come with biased results. And so you should basically go back to why are certain processes happening? Why has this the capability to yield more? And that is confrontational for the conventional research and thinking. But it has many, many implications. As I suffered myself from indoctrination at young age, it takes you a long time to get over it. Okay, that was the